So Michel, you've been working on development in the cooling industry for quite some time. So can you tell us a little bit about in your view, what are the most important trends when it comes to cooling in the data center industry?
I think the data center industry I don't believe it has converged to one unique solution which fits all applications. So I really believe that our challenge in carrier side and producers of equipment for cooling for data center is to be able to flexibly adapt to the needs of the customers. So I strongly believe also to modular design. It means that, as you know, the data center evolves with time, so we need to be able to provide the solution which can be adapted for the low load in the beginning of exploitation and then go to the highest load and be able to provide higher capacity going forward. So this is one element. The second element, we will have different approaches in different regions, so we will need to be able, I think the good trend is to be able to handle what we call different lift conditions, so with different temperatures in evaporator side to provide cooling. And I think this is a strong trend. The temperature inside data center will go up. So I think, if you look traditionally of cold water production, we were used to have units which were suitable to produce water on between 7 and 10 degrees C living water temperature. In the future, this water temperature will go probably to 30, one day maybe 50 degrees C. And mechanical cooling may be needed because it gives us opportunity to bring the energy level to much higher temperatures than today. So today, for instance, the typical temperature is 30, 35, 40 degrees C in the condenser side, so high rejection side if you wish. And we see the evolution for maybe 100 degrees C or 120 degrees C, when this energy can be valorized by industry or heating or food industry, for instance, and give additional perspective for usage of the heat.
So what kind of development of the compressors and the heat pumps are you doing in order to make heat recovery more technically feasible?
So there is probably three major elements which I will mention here. You are probably familiar with new generation of refrigerants, which gives us some possibility to rise temperature in the systems. We are moving also to multi-stage systems. So we are moving from one-stage centrifugal compressor to two-stage. We are thinking about also what we call compound system, when we can have temperature difference very, very high, and we can use two machines, one for the lower temperature, another for the higher temperature, and bring temperature levels to 90, 95, maybe even 100 degrees C in the foreseeable future. So this is one trend on the chiller, and another one is advanced system architecture and system controls. It's relatively delicate today, for instance, to have the chillers which can control in the same time living water temperature in evaporator loop, which is actually customer side. They want to have in data centers stable and constant temperature, for cooling perspective. And then if we are trying to adapt to the heating requirements, for instance, if you are connected to heat networks in the cities, people expect also to have constant temperature. So it's a kind of complicated usually to have the two temperatures satisfied. So we are finding the ways of adapting our chiller to be able to do both. Have variable flow, for instance, in condenser, fixed flow in evaporator, and by smart controls adapt operation of the chiller in such a way that we can provide good cooling and stable cooling in one side while providing stable temperature in the heating side. So integration, controls, and smart architecture. Coming back to architecture again, we see more and more opportunity to assemble 2, 3, or 4 chillers as a system and go from what I would call Rankine type of the cycles more to Lorentz type of the cycle with high temperature gradients in condenser and evaporator while optimizing efficiency. So this is next step also of our research.
So there is a lot of talk in the industry. And I'm talking about the industry in terms of data centers using and requiring process cooling rather than air conditioning. Mm-hmm. There's a lot of talk about non-mechanical cooling, so that they throw out the chillers, they throw out the compressors. Coming from Carrier, this might be a little bit of a challenge, right? I mean, the Carrier Corporation is built on chillers and heat pumps. So what exactly is the future of the compressor in the future for process cooling?
You may be surprised, but as I leave Carrier is not the chiller or compressor company. This is energy transformation company, and we do airside product. We do some special devices to transfer energy, and I'm sure that we'll not be lagging behind, the competition. If there is a new technology coming, we are looking, magnetic cooling. We are looking on very specific technology which not requires compression and Rankine cycle type of technology. Having said this, I still believe that for a couple of years to come, particularly given the opportunity we may have with higher temperature application, we will still come back, to the thermodynamics and the second law of thermodynamics. Then you have to have, temperature gradient to transfer energy, and you will have, Carnot cycle to be satisfied. And still there is some challenges in the new so-called new technology, whether it's Peltier effect or magnetic cooling or some other type of things, to reach decent level of efficiency with relatively high gradient of temperatures.